This conference will now be recorded.
Yes, Rakesh, I'm going to. That one I've not yet started how to remove. Today I'm going to show how to remove that. Today I'm going to show you how to remove that. Please follow my steps, whatever I'm going to execute now. I'm just going to brush it up for 5 minutes. So I'm going to read a data set called as cars from my local system. That is my 81 observations and 5 variables. So now I'm going to attach this data set called as cars. Here I'm just checking with respect to my summary of my cars. Summary is nothing but I'm just viewing the basic statistics details of my all the columns. So I'm going to plot my scatter plot. This is your y, this is your x1, x2, x3 and x4. Out of this we identified that between this and this there was correlation problem between volume and weight, and also between your HP and your SP we had a correlation problem. So this is called as your multi-collinearity problem. The value we got for this is 0.97 and this one it is 0.999 or something. So this is based on your scatter plot. We got the confirmation that there is a correlation problem. So in order to find your correlation values, that is a small r, correlation coefficient value, we used a function called as COR and the data set name called as cars. Then you are going to get your correlation matrix. So let me try to execute this line of code. So if I execute this line of code, I'm going to get between HP and SP, it is 0.9738481, and between volume and your weight, you can see that it is 0.999. Either you can write it as COR of SP, HP, or you can write COR of HP, SP. COR of HP, SP. It is either one and the same. See here. You can see here it is between SP and HP. Again, it is this one is 0.9738, and here you can see that between HP and SP it is 0.9738. So these are your values. Either it is one and the same. You can write x comma y or y comma x, or x1 comma x2 or x2 comma x1. So you came to know that this one and this one is having correlation problem. So post that we went to identify with respect to y, implementing your multiple linear regression by using a function called as LM. LM stands for linear model, and this MPG is nothing but your output. Volume plus HP plus SP plus weight is nothing but your input variables. Data is nothing but my cars dataset. Cars dataset model.car. Model.car is nothing but my new model name I'm going to create. So after creating this, I want to see the output, so that I've used a function called as summary of model.car. Post that, I'm going to just see are my variables significant or not. You came to know that volume is not significant because it is greater than 0.05. This p value is greater than 0.05, and you can see here also it is weight. So weight was also having problem with respect to your significance because it is greater than 0.05. As I explained you that you cannot delete directly weight or volume, so we went with respect to identifying which particular variable is having problem with respect to volume or weight. So we tried to build separate model for volume, separate model for weight, and combine these two variables and built one more model. That is your one more model we built. Then after identification of this, we came to know that still there is collinearity problem. So I'm going to execute that. See this line number 31. It is your LM, MPG is your output, tilt operator, volume. So I'm going to build a separate model for volume and see the output of this. See the output of this. Now you can see here the output of this model says it is significant. Output of this model says it is significant in the sense volume is significant. Yesterday I gave an example of your boys and girls. So similar to that point, it is your volume and weight. Volume and weight. So the next point is with respect to your weight. We need to check it out with respect to your weight. So with respect to your weight, I'm going to build one more variable, one more model here saying that your y is nothing but your MPG and your weight. So after building this model, we need to see whether that is accurate or not. Means your p value is significant or not. So I'm going to run this line of code. See, even your weight is also significant. So you came to know that volume separately, that is also significant, weight, that is also significant. Now I need to combine these two and check whether it is significant or not. Significant or not. So let me try to run one more model, that is your volume plus weight. You can see input is volume plus weight, output is your MPG. Output is your MPG. I'm going to run this line and see the summary of this model. See the summary of this model. So if you see that there is again a collinearity problem. Again a collinearity problem because volume is 0.48 which is greater than 0.05 and also weight is also 0.62 which is greater than 0.05. 0.05. So there is a problem with respect to this. There is a problem with respect to this. So yesterday some of them suggested that we need to remove weight because you are having more p value when compared to your 0.48. So before deleting, I told you that we need to follow some steps, right? As I told you that boys is your volume and girls is your weight. So before removing all the girls or all the boys, you need to do influential records. You need to identify which are those influential records out of 41 boys and 40 girls, which are those students which are creating nuisance in order to become my variable significant. In order to become my variable significant, I need to identify. So this is what we have identified till yesterday. Till yesterday, apart from that, I also ran this line of code, right? Influence dot measures. You need to install a package called as mv influence car mass, yes, and also VIF function, VIF. So install all these packages and just try to run this line of code called as influence.measures. This influence.measures is a function and you need to pass your original model including all the input variables, whatever the model you have built. You need to pass that model as your, you need to pass that model you need to pass that model name in order to check which one is significant or not. Means which one is your influential record. So let me just run this line of code and see. Here you can see. Okay, so yesterday we identified that there is a problem with respect to these influential records. This one, this one, this one, this one, this one, this one, this one. So totally we have some here and also we had somewhere first one and ninth one also, right? Somewhere we had first one and also ninth. Here. First one also we have a problem, ninth one also we have problem, and this star indicates that these are the influential records. Yesterday we have discussed until this point. Any questions until this point? Any questions? Okay, fine. So now, so let me just use a function called as influence index plot. Influence index plot, I'm going to use it. So influence index plot will try to plot, and you'll be able to see some of the influential records, top 2 or top 3. It will try to identify, and it will just display those, not display everything. It will display everything, but it will highlight top 2 or 3 influential records. So for that, you need to use a function called as influence dot measures is your values part. So influence index plot is a function which is, you need to pass your model, that is your first model, whatever the HP, volume, SP and weight you have built, the original model, you need to pass that. After passing this, it will plot your index plots for your influential measures. Influential records will be identified. Let me try to plot you and explain how that particular plot looks. So I'm going to open an external window, and then I'm going to use it with respect to my influence index plot. Okay, for this you need to install a package called as MV Influence. I've already installed it. Let me just make sure of using all those things. MV Influence. And also I think I need to use a package called as MASS. So let me try to plot it now. Influence index plot, and see whether it has been plotted or not. Yes. See, this is your influence index plot. It is called as your diagnostic plots. Okay, see, this first plot is nothing but your Cook's distance. So Cook's distance is an influential measure plot. So if your Cook's distance values are greater than 0.5, Cook's distance values are greater than 0.5, that indicates that is your influential record. See, this Cook's distance identifies if it is greater than 0.5, but here one is 0.5, greater than 0.5, and you can see this is highlighted. I mean, this is also highlighted. 77 and 71 has been highlighted. So the general thumb rule is, if your Cook's distance value is greater than 0.5, that is your influential record. But here it has identified top 2 influential records. That is your row number 77 and row number 71. Row number 77 and row number 71. Okay, I'm going to explain in a simpler way. Consider that you have written your exam. So consider that yesterday I gave an example of your college, right? So consider that this is your physics lecturer, this is your chemistry lecturer, mathematics lecturer, and biology lecturer. So your physics lecturer identifies that this is your Cook's distance part. So 77 and 71. So register number 77 and 71 is my most culprit students in my class. Your physics lecturer is going to give a complaint on roll number 77 and 71. Got it? So your physics lecturer is going to identify two students in a class, and is going to give a complaint against register number 77 and 71. The second one is called as your studentized residuals. Studentized residuals are nothing but your error part. So with respect to your errors, it will also try to identify top 2 influential errors which are creating nuisance in my data set in order to become my variables significant. So you can see here, this is also been identified 77 as top one, and second one is 1. register number 77, and one is been identified by your chemistry professor, and he is going to give a complaint to your principal saying that these two are my students who are creating problem in my data or my model.
We don't have any levels for this here, unlike Cook
One second.
distance.
We don't have any specific level for this. For student as residuals, we don't have any specific levels for this. It will try to identify the most influential errors. That's it.
Okay.
Only for this, we have a general thumb rule of 0.5. This is also general thumb rule. See, because it is one is greater, but another one is less than 0.3 only. But even though it has been considered as your influential record, I'm telling this for this, it is thumb rule is 0.5. 0.5, and this is called as your p-value. This is something like your probability value. So here also it identifies whichever the probability value is greater than with respect to single record. It is your 1 and your 77. See, your Cook's distance, residuals, and also Bonferino's p-value, all three are identifying 77, 77, 77, and here it is 77 and 1, here it is 77 and 1, here it is 77 and 71. So it identifies that these are the influential records. For this Bonferino's p-value also, there's no any particular thumb rule, but the thumb rule what we say is greater than 0.05. Greater than 0.05. So this one you need to keep into consideration. This one you need to keep into consideration. And if you see your at values are nothing but your predicted values. At values are nothing but your predicted values. If you're predicting some values, you are having higher prediction. It is something like your over prediction you are doing. So that is also with respect to your 77th record and 71st record are predicting very high when compared to rather than others. So that is the reason this 77 and 71. This is your biology lecturer is also giving a complaint on 77 and 71. So now tell me, out of these four plots, physics or else your Cook's distance, residuals, Bonferro's p-value, and your hat value, which one we need to remove first? Which one to remove, Rakesh, first? Yes, most of them are telling that we need to remove 77 because everyone are giving complaint against 77 first, and second is 71, 71 and 1 and 1 here. Here also 1, here also 1. So let me try to remove your 77 first and try to see is there any difference in my model. Is there any difference in my model? Let me just check it out. Let me just check it out. So now apart from this, if you want to plot it directly, you can use a function called as influence plot, and same pass your first model, that is your original model, influence plot, and you can see that there is one more plot I'm going to plot. One more plot. It also identifies some records. See here, influence plot also identifies that it is 77, 71 and 1. It has identified top three influential records, and this one we need to remove. First, see, if you see this, it is outlier, something like identified as an outlier. This bigger circle indicates that probably this might be your outlier. This might be your outlier. And also you can see that there is some values. There is some values. This also identified 171 and 77 influence plot. A user-friendly representation of the above. This thing, whatever I have written with respect to that, you can see that these three records have been identified as your topmost influential records. Topmost influential records. So let me just try to add one more column called as id dot or a parameter called as id dot n equal to 5. Okay. So it has not identified id.any is equal to 5, even though if I have given 5, it has not identified. Most of the records are fine, but only with respect to these three records are having problem, that is 171 and 77. So let me try to remove one or two and see how the model works. Okay, so earlier, like until last month, I remember that if you run this influence plot, you were never getting this, you were never getting these three values here. It only used to give you the plot, but now you are getting these three values also in your console, saying that this first record, 71st record and 72nd record is having highest influential records. If you see this values also, so values also, residual values is also greater. And if you see here, what do you call, hat value, this is also higher, and Cook's distance, this is also higher when compared to all others. So first highest is 77 and second highest is 2.42, 0.05, 0.65. I think this one you can take into this into consideration. See, and first let us try to remove 77th record and try to build your model. Try to build your model. What do you mean by car 1? What do you mean by car 1, Rakesh? Rakesh, car 1 is nothing but I'm building now. I'm building now. What do you mean by car 1? Hello? Where is my new set of variables? I'm not creating any new set of variables. I'm just removing that. I've just used that different into identifying the top 5 records. I'm just removing that. Rakesh. Just that's it. I try to identify with respect to top 5 influential records. That's it, Ram. Yes. Now I'm going to build a new model, that is by removing your 77th. Okay. See here. I'm going to build a new model, that is model.car1, model.car1, lm mpg tilt operator, volume plus sp plus hp plus weight. Same, all the input parameters I'm passing, but I'm only removing my 77th record. Means anything written in your square parenthesis rows comma columns. So I'm giving it as dataset called as cars and minus 77. Minus 77 means it will remove only 77th row. Minus means it is going to remove. It is going to remove that 77th record, and I'm going to include all the columns. So that's the reason I've left it as blank. So now I'm going to remove my 77th record and check whether my model is becoming variables becoming significant or not. Significant or not. So here I'm going to see a model has been built. Model has been built. Okay, I think it is taking the back line also. So let me just rerun this. Okay. See, after removing the 77th variable, sorry, 77th row, you are able to see that as it becomes significant, your beta naught, beta 1, volume and weight.
No.
No, right? So you identified that student number 77, sorry, record number 77 and 71, right? Now we have removed the 77. Even though after removing your 77th record, we are not able to make it as significant. So next what we have to do? We identified 77, we removed 77. Next what shall we do?
71 also need to remove.
Let us try to remove. So shall we remove 71 now? So let us try to remove your 71st record and try to build a model once again. Try to build a second model. So I'm going to remove, for example, in today's session, we are having 15 students. For example, I'm going to remove now Ram Shiva first. I tried to remove Ram, and next I'm going to remove Bharat. So Ram is having register number 77 and Bharat is having register number 71. So probably if I remove this, my entire class will become significant. I'm just checking it out with respect to these two. So let us try to do that. LM, MPG, volume, SP, HP and weight same as it is. Cars is minus 71 and 77. So if you want to remove more than one record, you should use a function called as C. It is your count of columns. So with, sorry, not the columns, it is your count, and you can use minus C of 71st record and your 77th record. I'm going to remove outside this bracket. It is your comma, means you're including all the columns with respect to these two records. So Ram is 77 and Bharat is 71. I'm going to remove these two students from my class. Earlier I removed only Ram, but my class did not become significant. So let me try to remove Bharat and Ram so that whether they are significant or not. See, I built a model. Let me just see with respect to summary of my model. Summary of my model. See, I built my model. See, volume is not becoming significant. Weight is also not becoming significant. Rather than that, after removing Bharat, your principal is also telling that that is your intercept. This is also greater than 0.05 right now. Your intercept. Earlier at least it was 0.04. Now intercept is also becoming 0.06. So then what we should do? Probably Bharat is principal's son. Bharat is principal's son. Okay. Now what shall we do? Then we go for first record. We can do that also. Let me try to do that. And instead of here, I'm going to just copy these two lines and I'm going to create one model. I'm going to remove Lahari also now from my classroom. I'm going to remove Lahari also from my class now. 3 minus 71. I'm going to write 1. First record also I need to remove. So that's the reason I'm writing it as 171 and 77. And I'm giving the name as 3 and model 3. Model.car 3. I'm going to execute it. Model.car. Okay, I need to run this line of code. So let me check whether it is becoming significant or not. Is it become significant after removing 1, 71 and 77?
No.
No.
Still
Okay.
no.
Then what you'll do? Then what will you do? Think and tell me the answer. What shall we do now? Come on. Think. What shall we do? Okay. So until and unless this point, please note down the coding. Please note down the coding until this point. I'll just take a 2 minutes break. I'll be back. Please complete the notes until this point. Next step I'm going to explain you. School idea. Okay. Yes, Debanshu, you're asking about this. You're asking about this, this, right? Yes. So anything written within your square parenthesis, like for example, rows, comma, columns, you can specify the rows. If you want to remove 0 to 10 records, for example, first 10 records, if you want to remove, you can give it as 0 to 10. And if you don't want to remove, if you want to keep all the columns, you can give it as just comma. Or if you want to remove a specific columns along with your rows, you can also specify, I want to remove my first column. So if I write it in this way, I'm going to remove my first column and also my 0 to 10th records. I'll show you, just see an example how to see that. So what I'll do is, I'm going to create a new variable called as car1. Simply, for example, I'm just creating a variable called as car1. Cars of minus 77, I'm going to give. Cars of minus 77, I'm going to give. Sorry. Sorry. See here. Earlier, your original data set is having 81 observations. I'll tell you, I'll come to that point. 81 observations and 5 variables. Now I've written only minus 77, means your 77th record has been removed. 77th record has been removed. So one record has been removed. So it became 80. It became 80. Now, along with this, I'm going to give, for example, I'm going to give 3, for example. Okay, I'm going to execute it. I'm going to execute. See, now, okay. See here it has become, your car 1 has come down to here. You can say that 89, 92, 90. Okay, let me just open your car 1 and explain you what it has done. Car 1. So this is your minus 77 and third column in the sense. Oh, I've just written 3. I've just written 3. See, wait. What I'll do is I'll just convert this into tabular format. It will be useful for your easy understanding. See, I've not written minus 3 there. You're able to get my point? I've not written minus 3 here. If I've written it as minus 3, then your minus 77 and minus third column would have been there. So now I've written only to remove minus 77 and I've only selected my third column. So I'm going to get it in this way. I'm going to get only the third column. Only the third column. It has been shuffled. Everything has been shuffled. So instead of that, what I'll do is, instead of 3, I'm going to write it as minus 3. So minus 3, what it will do? If I run this line of code, what it will do?
Remove the minus 3 columns.
Means what will be your output?
2 columns.
2 columns. It will not be 2 columns, I guess. It will be remaining 4 columns, right? It will only remove, it will only, see here, 4 columns. It will only remove your third column, which is present in your HP. First column is HP, second column is MPG. You have removed your volume. So your third column is being removed and your 77th record also will be removed. Your 77th record, see. I'll open both the data sets now. I'll open both the data sets and I'll show you the difference. 77th record, right? So let me open, see here. You're able to see the difference? 77th record is being removed because we have written it as minus 77, comma, minus 3, comma, minus 3. It has removed your 77th record and also your third column, that is nothing but your volume. If you want to cross verify, just click on this. Just click on this original data set. Your third column is what? Volume. So if you see your car 1, it says that it is your volume is being removed. Got the difference? Debanshu, Satish, Ram,
Yeah, right.
Mega. Now, so now we identified by removing all the columns, all the variables, sorry, all the records 77, 71, 1 also, then also you are not able to identify. So we cannot keep on removing all the students, whether your class becoming significant, 1 student, 2 student, 3 student, 4 student. So ultimately we need to come up with a decision whether it is volume is creating problem or weight is creating problem after doing all these steps. So let us try to go back to your coding part now. Let us try to go back to your coding part and let me explain you that line. So this is done and this is done and this is your, okay, let me add this also here. This comment I'm going to add it. first 77th and 71st observation I have removed. After that also it does not become significant. So I'm going for a function called as VIF. VIF is a function which is full form is called as your variance inflation factor. Variance inflation factor. This is the full form of your VIF. So this VIF says that variance inflation factor, and if your VIF value, so the general thumb rule is if your VIF value is greater than 10, means that particular variable is creating problem in order to form your collinearity problem. So here you can see variance inflation factor is used to check the collinearity between the variables, but the thumb rule here I mentioned it as VAF value greater. This is just a thumb rule. I'm not going to tell that it is a standard. I'm just telling if your VIF value is greater than 10, then that particular column exists collinearity among all the variables. So just take it as a thumb rule. Don't take it as stick to this value. It is just a real-time thumb value, whatever I've used in some of my projects. So now I'm going to use a function called as VIF, and I'm going to pass my original model called as model.car, which is the first model I have built. And let me see the values for your VIF. Let me see the values for VIF. See, volume plus HP plus SP plus weight. So here you can see that 638.80, 19.92, 20.07, sorry, 639.53. Now, which one is greater than 10? Which one is greater than 10? VIF values. All. So that is the reason you should not, so if you remove all the input variables, what you will be left out with only MPG, then you cannot build anything. So that is the reason I told you that your all the values are greater than 10. It is just a thumb rule. So whichever is highest, which one is highest VIF value out of all four? Your weight. Your weight is having highest value when compared to all others, that is your 639.53, and second highest value is 638. So if you see this in our original data set also, when we created your model, you are having a problem with respect to volume and weight only. Volume and weight only. So out of these two, you need to choose which one is having highest. Which one is having highest. So you should remove that variable. You should remove that variable. Getting my point? So you should remove this variable finally, and you should build your models with respect to three variables. So this is one way to identify which one is having collinearity problem, that is your VIF function. Apart from this, I'm going to show you a plot. Apart from that, I'm going to show you a plot. That plot also is called as your AV plot. AV stands for your added variable plots. Write down. AV plot stands for added variable plot. Added variable plot. So if I use this AV plot function, added variable plots to check the correlation between variables and the output variable, it will try to plot between HP and MPG. I'm talking with respect to input and output. Here it is your volume and MPG. One more chart. Third chart will be between your SP and MPG. And fourth one, it is weight and MPG. Okay, so if you plot it, you should get like either like this or like this or like this or like this. So if you get any of your variables, if you're getting like this straight line between your input and output, you should remove that particular variable. By using your VIF function, we came to know that we need to remove your weight. So if you get similar in your weight also, if you get a straight line like this, then we need to remove this. We need to remove this. So let us try to understand with respect to that. So added variable plots to check the correlation between your see, I'm going to execute. Before executing, I'm going to just open an external window because I've zoomed in. So let me try to plot it. See here, HP and MPG, volume and MPG, SP and MPG, weight and MPG, weight and MPG. So out of all this is having negative correlation, this is having positive correlation, this is your HP and SP has been ruled out. These two are success because they don't have any collinearity problem. So after building your model, there is not a problem with respect to these two. We had a problem with respect to only volume and weight, right? So if you see these two pictures, if you see these two plots, see, as I told you, right? So either it should be slightly like this, or if it is straight line, we should remove that. So what was the value you got when you ran for VIF function for volume? What is the value you got for volume just now? It is 638. Volume is 638 and this is 639.53, right? 639.53. So if you see this, so you can see slightly there is difference. Just slightly try to observe this line. It is above your zero line and it is closing below the zero line. It is slightly like this. It is slightly like this. But when it comes to your weight, see, it is almost straight line. So which one to remove? Your 639 or 638. Which one to remove now? So shall we go for weight? Shall we go for weight removal? Rakesh, as I told you, you should go for 639 because it is highest. It is highest, not the lesser one. You should go with respect to VIF value. Highest value, we need to remove that variable. Okay, so you can see here and so let me try to remove your weight column and try to build a model and see whether your volume is becoming significant or not. See here, final model. I'm going to build a name called as final model, and you can see here it is LM MPG tilt operator volume. See here. See, MPG volume plus SP. I'm going to run this model and store it in a variable called as final model. Oh, am I getting an error?
SP having space.
Okay, fine. So I've just built my model, that is final model. Let me try to run this line of code. Summary of final model. Is your volume become significant now after removing your weight?
Yeah.
Yes or no?
Yes.
Yes. So what shall we do now? So this is your final model. After removing your weight column, we came to know that there is a problem with your weight. So we have removed this weight variable, and then all the other variables became significant. All are less than 0.05. Then this is your final model. And also this, you can see your accuracy of your model. Accuracy of your model also you can see by seeing your multiple R squared value. Multiple R squared value. So the multiple R squared value is how much? The accuracy value of your model is 77. Means your
77.
model is 77% accurate. 77% accurate. Clear? Now, I'm going to give you one assignment question. Write down your assignment question. It's a theory research associated question. What is the difference between multiple R squared value and adjusted R square value. You're having here, see here, adjusted R squared value is 0.76, multiple R squared value is 0.77. You should tell me what is the difference between these two, adjusted R squared value and your multiple R squared value. And if you are telling me your Google answers, if you are telling me your Google answer, not a problem, but you should explain me in a layman terms. You should explain me in layman terms. I'll give you 1 or 2 days of time. I want you all to do this. Write down this question. What is the difference between multiple R squared value and adjusted R squared value? Okay. Now, you can see that your accuracy of the model is 77%. Your client says that I don't want 77%. I want you to increase 85%. What you are going to do? What are you going to do now?
Transformation.
You can go for transformation. You can go for transformation. So let me just try to, just for your example sake, I'm going to run here with respect to your transformation. So it is here I'm going to use
Log.
log. So I'm going to run this model. I'm going to name it as just not final model. I'll just type it as TR model, transferred model, transformed model, TR model. See, I'm going to execute this line of code. TR model. See, got the difference?
91.
Bharat, Rakesh, you're able to see here, right? All the variables are significant and the accuracy of the model is increased to greater extent. 91%. 91%. So adjusted R square value is also 90%. So if you do your transformation, your accuracy of the model will be increased to a greater extent. It depends on the data. See, I'm not telling that if you just use log for every algorithm, it is going to increase. It might also decrease sometimes. It might also decrease sometimes. So I'm just giving an example. That's it. So I'm going to show you one more transformation. Let me apply log on your output variable. This is called as your exponential model. Exponential model. I'm going to just give it as exp model. If you apply log on your output variable, that is called as your exponential model. Let me run this line of code and execute it. See, if you apply just on your output variable, you are going to get, earlier it was 77, 76 or 77, it has increased to 79. So if you apply log transformations on your input, it is going to give you 91%. 91%. Or else what I'll do is I'm going to apply log transformation on both input and output, on both input and output, and let me try to run this once again. See, if you apply on both the sides, again you are getting 86%. So first was 76, first was how much? 76, then you got 91%, then you got 79%, then you got 86%. Out of these four, which one will you choose?
86.
Hmm?
86.
86. Why? 91 is there, right,
Because,
Bharat?
yeah, but no, this is the bunch.
Yeah, Devanshu. Why?
The requirement was 85, right? So,
No. See, okay, requirement was 85, so you will choose 86. So
yeah.
I'll just give one simple example. I'll just give you one simple example, Devanshu. Consider that your appraisal is pending this year. Appraisal is pending this year. You will be expecting 12% hike this year. If your manager gives you 20% hike, will you accept only 12% and remaining will you leave it? Yes
No.
or no? No, right? So even though if your client is expecting 85%, give him 91%. Will you be happy or not? Will you be happy or not
Yeah.
if you get 20%?
Yeah.
It is like that. It is like that. Choose always a best model which is having highest accuracy. Don't go if your client is telling 85%, don't only try for 85%. If your parents say that if you get distinction, I'm going to get you a bike this year. Hmm? Will you only try for 75% exactly, or if you get 90%, will your parents not get you a bike?
Yeah. Yeah.
Yes, it's like that.
Like,
It's like that. So always go with 91% or best model, whichever is having highest accuracy rate.
but the data is not changed, right?
Yes.
So how does this
Data will never
transformation?
change. Transformation in the sense your data will never change. See, I'll give you one more simple example. Your first semester you got 60%. Okay. Your parents will tell that, hey, I want you to get distinction. In second semester, you'll get 68%. Third semester, you'll get 73%. Fourth semester, you're going to get 80%, for example. Okay. Now, does your parents change you? You are the data. No,
No.
right? You are putting some more effort, means you are transforming yourself from a normal average student to a distinction student step by step, right? So your data, you're transforming and making your data as to give you a better accuracy. It's like that.
Okay.
Got it?
Yeah.
Okay. So what is your this thing assignment?
Multiple R square versus
Question. At least tell me the question.
Difference between adjusted R square value and multiple R square value.
Yes. So if you are giving me Google answer, I'm telling you now itself, don't give just blindly the Google answer. I want an understanding answer from you all. Try to do some research, whatever, whether it is on YouTube or whether it is on some other sites, not a problem. Just spend some 30 minutes of time. Just spend some 30 minutes of time, do research. Because why I'm giving this assignment is in your real-time projects also, as I told you that your data science projects are not something like your come by morning 9 o'clock, go by 6 o'clock. It will be very flexible than this job. But the thing is, everything will be a R&D. Everything will be a trial and you will predict that I'm going to get promotion this year. I'm going to get promotion this year. You might not get. Why didn't you get? You need to do some research. You're telling that today it is going to rain. Based on your some historical data, it will not rain. Okay, fine, not a problem. But this is how your real time works. Got it? Hmm? Okay. So let me just go back to your code once again and try to plot your final model. Whatever the final model we have built, I'm going to show you that plot of final model. So before plotting that final, okay, let me just plot it. See, here I need to click enter. Okay, let me open one external window. Let me explain your plot of final model now. Click on next. See, so this is just for your understanding purpose. I'm showing you this. So it is nothing but your residuals. Residuals are nothing but your errors, and this is your predicted value. Fitted values are nothing but your predicted values. So if you say this, as I told you that your error should not have any cyclical trend like this. It is approximately constant. It is approximate. I told you, even though you'll not be getting a straight line, you might get similar to your like this or something. So you got it like this. So it is called as your homoscedasticity. Homoscedasticity. One more chart I'm going to show you with respect to your errors also. So I need to click on this next. Click on next plot. See, residuals. If you plot your residuals, it should follow normal distribution. As I explained you this term, you remember linearity of the model, independent and identical of your errors, and normally distribution with respect to your errors, and your input should be equally reliable. So inputs we have already checked with respect to your volume, weight, SP and HP. Now we are discussing about your errors. We are discussing about your errors. Your errors are normally distributed. Your errors are normally distributed. See, here also your studentized residuals identifies that 77th record, first record, and 71 record is highlighted as your influential record. Influential records. Now let me click for next plot. See, again, it is your standardized error, means whatever the errors we have seen, it is square root of your errors, standardized errors. So this also says that it is approximately constant. Approximately constant, it indicates that it is nothing but your homoscedasticity. Residuals are nothing but your errors. Next plot. See, this is your standardized residuals values with respect to identify your influential records. See, here also it is saying that it is outer than, as I told you, that Cook's distance, right? So your Cook's distance values indicates that is your red dotted line. Red dotted line, if it is crossing that red dotted line or close to that red dotted line, that indicates that it is your influential record. So you can say that greater than 1, 77 is greater than 1, and this 77, sorry, which one it is? We identified 71 is also close to your 0.5. So these two are being considered as your influential records. Influential records, whichever is having closer to this record. And also we identified one more. So this is your Cook's distance part. Cook's distance part.
Yogesh, this is
Yes.
Bharat.
Yes, Bharat.
I got one confusion here.
Yes.
Um, the basic assumptions of linear regression, you told that line that you
Yes.
have told, right? Linear
Yes.
with respect to the parameter and independent with respect to the error, and the error
Yes.
should be normally distributed and equally reliable.
Equally reliable should be your input variables.
Yeah. There, when we plot the AV plot, equally reliable means the input should not be It should not be
See.
a independent. It should be an independent variable, and it should not be a dependent variable.
No, inputs, see, one thing, Bharat, always your input variable is called as your independent variable. Okay. So if you are writing with respect to MPG with HP, this output is dependent on input. Or if you are writing with respect to MPG with volume, this is dependent on this. MPG is your output, SP is your input. So this is dependent on this. But I'm
Correct.
talking with respect to inputs. If you're
Yeah,
writing it as
volume.
HP is equal to volume, these both of them are independent variables, right? Inputs are, both of them are inputs. Both of them are independent variables. They should not be like this, or they should
Correct.
not be like this. Right? So that
Yeah.
is what I am explaining. In your AV plot, you will be able to see between input and output. If anything is approximately, if your input and output should be like this only, or it should be like this. If your input and output, this is your input X and this is your Y, it should not be straight line. So this is what we got it into weight, right?
Yes.
Yes. So that is the reason I'm told you. Okay. So Bharat, sorry. One more question from Rakesh. So Rakesh, Cook's distance is nothing that there is a standard. There is a standard. This Cook's distance is nothing but it will try to identify the each and every records what is the distance. What is the distance? I'm going to show you with respect to clustering what is the distance. I'm going to explain you, but here it is of no use. Here it's of no use. So Cook's distance thumb rule, keep it as if it is your greater than 0.5, that particular that particular record is created as a problem. Got it? One sec, give me a second. Hello. Rakesh, if it is greater than 0.5, I'll explain you what is distance in coming days. Distance is, that is also a part of your syllabus. I'm going to explain you when I explain you a topic called as clustering or segmentation. That is your third algorithm, not third algorithm, first, second, third, fourth, fifth algorithm. So fifth algorithm, when I explain you that, I'm going to explain you what is your distance. What is your distance? Okay, but as of now, just remember, if it is greater than 0.5, that is your influential record. That is influential record. Got it?
Hello.
Yeah.
Yeah, here even 79 has been highlighted, right?
Yes, I mean, yeah, that is what. See, that is what I showed you, only three variables. That is what I showed you, only three variables. So if you want, you can remove this also, this also, this also. How many variables will you keep on removing? That is my question. Now it is only 81 records. Out of this 81, you can do manually like 8 or 10 records you can remove. Suppose if you're having 1 million records, out of this 1 million, there are 10,000 influential records. 10,000 influential records. Will you keep on removing all 10,000 one by one, Ram?
No, we can't.
No,
No.
that is the reason I did not show for all the records. I just showed one or two variables, and then apart from that, then I went into your VIF function to identify your influential variable. So we came to know that weight is having highest VIF value. Based on VIF value and also based on your AV plot, we can see that this is what the creating the like in order to your variable to become significant, this weight variable is creating problem. So that is the reason I did not go with respect to this.
Okay.
Okay. Okay. Now coming to this last line of code. So you need to install a package called as mass. After installing a package called as mass, there is one more function called as step AIC. So this step AIC function, what I'm going to do is, don't use it as a regular practice. Don't use it as a regular practice. This is something like an interview saver. Interview saver. Concentrate on my words. It is something like your interview saver. So your interview saver means, suppose you know only this function called as LM. You don't know how to remove your AV plots, VIF function. You don't remember that influence index plot, influence measure plot, nothing you don't know. You don't know anything, but you only know this LM function. But you don't know which variable to remove or which record to remove. So if you use this step AIC function, build one model, first model including all the input variables. That is your model.car, whatever I built it. So like that, build one first model including all the input variables, pass that variable name, the model variable name, into a variable function called as step AIC. Step AIC. If you run this, it is going to build multiple models, and now we have stopped at volume plus HP plus SP. First model we have built with volume plus HP plus SP plus weight. Volume plus HP plus SP plus weight. I'm going to remove this, and based on that I'm going to build a model. So what I have to do is, now I'm just passing my first model name and using a function called a step PIC. It will only automatically delete this weight variable and it will stop at this particular model. It will stop at this particular model. So let me run this line of code. So let me try to zoom it. Step PIC model dot car. See, in the first model it has built MPG volume with HP plus SP plus weight, and in your second model it has removed automatically, weight is removed here. See, weight is removed automatically and it has only taken with respect to volume plus HP plus SP, and it has generated AIC. It has been generated with respect to 248 value, and this is your 246 value. So if you see this AIC value, AIC stands for archaic information criteria. Archaic information criteria. So this archaic information criteria value indicates that lesser the AIC value, note down this line of code. Whatever I'm writing, lesser the AIC value, better the model. Lesser the AIC, better the model. So out of these two models, you can see that AIC value is being displayed here. So out of these two, you can see that first one is having 248 as your AIC value, and this one is your 246. 246. 248 or 246. So lesser the AIC means this AIC model is less than your 248. So you can see that your lesser the AIC means you should choose this way a model that is after removing your weight variable. We need to go with respect to volume plus HP plus SP and your MPG and your MPG. So just use it as an interview saver. And suppose if you want to get confirmation of your model, whether the model you have removed your weight variable correct or not, see, now it has automatically done this. You can just get it as a cross verification. Cross verification. Cross verification.
This can be used for even any number of columns, right?
Yes, it can be used for any number of columns. See, if you are having, for example, I'm going to tell you, see, LM, Y, tilde operator, X1 plus X2 plus until X50. You're having 50 input variables and you'll try to build one model. All the input variables you are using and you're building a model. You don't know this step AIC, sorry, influence index plot via your function. You'll never remember all these things. So directly go for step AIC. Step AIC function and pass this model name. I'm giving it as M1. So if I pass this M1 model, it will only try to build the first model with all the input variables whatever you have passed, and second iteration it might remove 2 variables, in third iteration it might remove 3 variables, and whichever is having the least AIC value among all these things, choose that one as your best model. Choose that one as your best model. Got it?
Yeah. Okay. Just one more thing.
Yeah.
Yeah, just out of curiosity, like Why can't we just directly go for this stepwise instead of all those things? As you know, if agricultural purpose is fine, okay.
So fine,
Just like in
fine.
case of
Yeah, I got your point. I got your point. If see, this is just a model that has been built by one of our community member. Suppose if you are not doing all those things, we removed 77th record, right? And 71st record.
yeah,
Yes. So
yes,
if you remove 77th record, if the problem was solved there only,
okay,
then it wouldn't have been displayed this. It wouldn't have been displayed this. It would have stopped at this point only. First model only. Then what will
okay,
you do?
okay. Then we need to search why which has been removed, which has been
That is the
removed.
reason you should do all those steps. I'll show you when I implement your logistic regression. I'll show you that step also. I'll show you that step also.
Okay.
Okay. Now, as per your question, simple question, I'm going to do simple change here. See here. Consider that you're having only 3 models. You're having only 3 variables. So I'm going to use this step PIC function. Instead of passing my model.car, I'm going to build my final model. So your final model is having how many variables? 3 variables, right? Volume plus SP plus HP. So if I pass
Yes.
this line, then obviously it should pass or it should go for next iteration. Consider that I'm taking an example. Volume plus SP plus volume plus SP plus HP. So you can see here it has stopped at this point only. It has stopped at this. It has not gone for one more iteration. Then what will you do? So that is the reason you should do all these steps. If you know it is well and good, right, Ram?
Yeah,
Yes.
yeah, that's right. For education purpose, yeah.
You should know it is. So this one I'm showing you just for your cross verification point of view. You can just check it out. Don't directly jump. That is the reason before explaining this line of code only I told you that don't think this as your final this thing. Just use it as an interview saver. Okay. So tomorrow are you all available? How many of them? Bharat, I told some of them yesterday. They told that no, some of them are not available. I think some of them have moved today only. I guess Lahari and all. Lahari, Mega and all have moved today itself. Bharat is also no. How about Neha? Neha, are you available? Okay. Tomorrow and day after, don't want. Ram, how about you? Okay. I think most of them are
I'll be
telling that.
available.
Okay, only 3 to 4 people are available, and some of them are telling that we are not available. We are not available. Okay. On account of Ganesh festival, we'll have 2 days break. Is that fine, everyone? Is that fine? Because again, if I take the session, I have to go for again twice. I need to go for a backup class. So that's the reason I don't want to do that. So at least take these 2 days of time and try to complete your backup videos and try to do some research on your adjusted R squared value and also your multiple R squared value. Okay. So wish you all happy Ganesh Chaturthi. Okay.
Thank you,
Thank you all.
Lokesh.
Thank you. Thank you all. Good night. Thank you. Thank you.